All right, so we're going to keep working in the second trig packet. And Friday's assignment kind of got you ready for what we're going to do today. But I'll still kind of go slow in case Friday you got a little confused about what was going on. But the first thing we're going to do today is to find the 6 trig ratios of the quadrant angles. And our quadrant angles are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and also 360 degrees too. All right, so what we're going to do when it's a quadrant angle where it lies on an axis, either the x-axis or y-axis, is find a point that is at that angle. So let's just start with 0 degrees. So we're going to just graph a point at 0 degrees. And we're going to think of that point as being 1 unit away from 0. So that means this point is graphed by going 1 unit to the right. So 1 unit to the right is going to be the point 1, 0. All right, so our x is 1, our y is 0. And then r is the distance that point is from 0. So that point is 1 unit away. So r is 1. And so that's what we did. We didn't do the r on Friday. We just did the point. But now we're going to use x, y, and r to find the sine, cosine, tangent, cosecant, secant, and cotangent of 0 degrees. And so hopefully you guys just did well on the quiz where you needed to know the x, y, and r rules. But if we want to find the sine of an angle using x, y, and r, it's going to be y over r. The cosine of an angle is going to be x over r. And the tangent of an angle is going to be y over x. All right. So we'll just use the x, y, and r we just talked about. So to find the sine of 0 degrees, we're going to put y over r. So 0 over 1 is 0. Cosine, we're going to do x over r. So 1 over 1 is 1. Okay, and then for tangent of 0 degrees, we're going to do y over x. So 0 over 1 is 0. Right, and then for our reciprocal functions, we're just going to flip over what we just found. So we take 0 and do the reciprocal of 0. So sine of 0 degrees was 0 over 1. When we do the reciprocal of that, we get 1 over 0. Anytime you have 0 in the denominator, the function is undefined. So the cosecant of 0 degrees is undefined. So the reciprocal of 0 is undefined. All right, and then the reciprocal of 1 is just 1. And then for cotangent of 0 degrees, it's the reciprocal of 0 again, and that's undefined. All right, we are also going to go ahead and do another one. We're going to do 270 degrees. So a point at 270 degrees, we just went down 1 unit. So let's move over to 270 degrees. All right, so down 1 unit is over 0, down 1. So the point 0, negative 1. So the x is 0, the y is negative 1, and then r should be 1 because it's 1 unit away from 0. That point is. Okay, so then we'll use our x, y, and r rules. So when we want to find the sine of 270 degrees, it's going to be y divided by r, or negative 1 divided by 1. The cosine of 270 degrees is x divided by r, or 0 divided by 1. And then for the tangent of 270 degrees, it's y divided by x, or negative 1 divided by 0. So anytime that 0 is in the denominator, it's undefined. And then we will do the reciprocals. So the reciprocal of -1 is also -1. The reciprocal of 0 is undefined. And then the reciprocal of undefined is actually 0. So we take -1 over 0 and we do the reciprocal, it gives you 0 over -1, which is just 0. So 0 in the numerator is 0. 0 in the denominator is undefined. So that's how you do the trig ratios of a quadrant angle. Now, part of your assignment tonight is to go back and do 90 degrees and 180 degrees. And then the rest of what we're doing today is on page 5, mainly 6. So on page 5, it talks about what I did in that on the Friday video that you guys did. And so if you understood that, you're going to be way ahead. So that's going to be really great news. But it shows the ratios of 30, 60, 90 triangles and 45, 45, 90 triangles. So for a 30, 60, 90, the side opposite of 30 degrees is 1. The hypotenuse is 2. Opposite of 60 degrees is the square root of 3. All right. And then for the 45, 45, 90, both legs are 1. And the hypotenuse is the square root of 2. So on both triangles, the hypotenuses both have a 2. So the 30, 60, 90 one is just a regular 2. The 45, 45, 91 is the square root of 2. So there's lots of little things you can do to help you remember, but it's crazy important that you can remember those ratios. Okay, so for page 6, we are going to do some of these together, and anything that we don't do on this chart, you're going to need to go back and do on your own for your assignment. So for 30, we're going to do 30 degrees together. So for 30 degrees, this one doesn't have a place for you to draw the triangle, so I'm going to just kind of move it over to the side. 30 degrees is in quadrant 1. So I'm going to draw quadrant 1. I'm going to draw an angle coming out. All right. The 30-degree angle is this one here at the origin. Oh, so small. All right. So I know I have a 90-degree angle. I know I have a 30-degree angle. So the other angle is a 60-degree angle. And I know opposite of 30 degrees is going to be 1. The hypotenuse is going to be 2. And opposite of 60 degrees is going to be the square root of 3. All right. Now in quadrant 1, I know all of my trig ratios are positive, so that's awesome. So I'm just going to do SOHCAHTOA. So for the sine of 30 degrees, I'm going to do the opposite over the hypotenuse. The cosine, I'm going to do the adjacent over the hypotenuse. And then for the tangent, I'm going to do the opposite over the adjacent. Now we are not going to leave radicals in the denominator, so we'll simplify that down. Okay, and then I just need to do the reciprocals of those. So the reciprocal of 1/2 is 2. The reciprocal of square root of 3 over 2 is going to take a little bit of work, but not too bad. And then when I go to do the reciprocal of the cotangent, I'm going to go back to this part and flip it over. It's going to be the square root of 3. All right, now when we get out of quadrant 1, it starts getting a little more difficult. So any multiple of 30 degrees, 45 degrees, or 60 degrees is considered a special angle or a quadrant angle. So we can compute the trig functions of these angles by drawing them, establishing the quadrant, and filling in the signs using all students take calculus. And we're going to find the reference angle, which we talked a little bit about on the video, but today I think hopefully it's going to make even more sense. And then that's going to make your reference angle should be one of the special angles, 30 degrees, 60 degrees, or 45 degrees. And then we'll just draw our triangle using our rules for 30, 60, 90, or 45, 45, 90. And then we should be able to figure it all out. All right. But the first thing that we have is writing this in radians. So I'm skipping around. So as you're filling in, please make sure you're at the right row. So you're not filling in something in the wrong place, because that will kind of be frustrating for you. So we have 135 degrees. We want to change that to radians. So when we're changing to radians, we multiply by pi over 180. All right. And you guys might want to grab a little blue calculator, or you can use your phone calculator as long as you're using it as a calculator and not as a phone, and Miss Higdon is, or whoever your sub is okay with that. So we are going to simplify this down, because 5 definitely goes evenly into 135 and 180 degrees. So I'm going to take 135 and divide by 5, and that's going to give us 27. We still have a pi up there. All right, then I'll take 180 and divide by 5, and that's going to be 36. Okay, and that will reduce again. So 9 also goes evenly into both of those. So I would divide 27 by 9 and get 3. Divide 36 by 9 and get 4. Okay, so 135 degrees is the same as 3 pi over 4 radians. Okay, so then I'm going to do the drawing. So 135 degrees is in quadrant 2. So I'm just going to draw quadrant 2 here. And I'm going to draw an angle coming out of the origin. Let me try that again. It's going to do it that way. All right. And then we're going to make a right triangle. All right. So the angle that is 135 degrees is this angle. So I want the angle that's inside the triangle, and the angle that's inside the triangle is the reference angle. So what I would do is I would take a full rotation. So we have a full rotation here, and then subtract away what I don't want. So I only want the angle inside. So I would subtract away this much right here. Well, that ends up being the 135 degrees. All right. So a full rotation is 100, not a full rotation, it's a half rotation, sorry. A half rotation is 180 degrees, and then I'm going to subtract away what I don't want, which is 135 degrees. So that's going to make my reference angle 45. All right, so inside there, I labeled it 45 degrees. So if your angle is an acute angle,
please excuse this interruption. This is a reminder that from 9:30 to 11 a.m., students are only allowed to go to their math, CTE, foreign language, fine arts, health, PE, ROTC, or driver's ed class. Teachers will dismiss students at 9:30 to go to those classes, or if students choose to leave, please check out with Ms. Gina before you do so.
Sorry about that. But anyway, if your angle is an acute angle, like 30 degrees, 45 degrees, and 60 degrees, that is the angle that's inside your triangle. If your angle is larger than 90 degrees, then the reference angle is the angle that's inside the triangle. So it's kind of weird, but that's how it works. All right, so let's label our sides. So our sides for 45, 45, 90 are 1, 1, and the square root of 2. Okay. And then we need to figure out our signs of our trig ratios. So in quadrant 2, if you guys remember, all students take calculus. In quadrant 2, sign is positive and the other two are negative. So I'll go ahead and make cosine and tangent negative. And then same goes for your reciprocal functions. Cosecant would be positive, secant and cotangent would be negative. All right, and then I'm just going to do SOHCAHTOA with that little triangle that I drew. So we're going to do for a sine, we're going to do the opposite over the hypotenuse. And then reduce that. All right, for the cosine, same thing happens. We do adjacent over hypotenuse. And then for tangent, opposite over adjacent. Right. And then once we get those, we just do the reciprocals. So when I do the reciprocal for cosecant, this is the one I'm going to flip. Right. So in the case of ones where the reference angle is 45 degrees, the sine and the cosine should have the same absolute value. So they may be exactly the same, or they just may have like one's a positive, one's a negative, because the opposite and the adjacent are both 1. So that would make the sine and the cosine be the same, at least the same absolute value. Okay, we are going to do another one, so don't worry. We're going to skip down, and we are going to do 240 degrees. So make sure you're on the right one. So we want to change this to radians. So we're going to take 240 degrees and multiply by pi over 180 degrees, just like we did in the last packet. Now, when there's a 0, it's so much easier to simplify because the whole 0 will cancel out. And then you have 24 pi over 18. And for 24 and 18, 6 goes evenly into both of those. So it reduces to 4 pi over 3 just by reducing by 6. All right, 240 degrees is in quadrant 3. So I will draw a triangle in quadrant 3. So the angle that's 240 degrees starts, let me draw it in red. Here, that angle is 240 degrees. And that's not the angle we want. We want the angle that's inside the triangle. All right, so what we would do this time is take the whole angle and then subtract away the part that we don't want. So we only want what's inside the triangle. So what we're going to subtract, I'm not going to be able to do it like I want to. We're going to subtract away this part right here. All right. So what that's going to be is the whole angle, 240 degrees, minus the part that we didn't want, which would have been 180 degrees. And that's going to give us a reference angle of 60 degrees. All right. Now, if I have a 60-degree angle and I have a 90-degree angle, that means my other angle is 30 degrees. And opposite of 30 degrees is 1. The hypotenuse is 2. Opposite of 60 degrees is the square root of 3. Okay, and then in quadrant 3, according to all students take calculus, tangent is positive. And the other two original trig ratios are negative, so I would do that. And then I would reflect it over here. All right, and then from there, we're just doing SOHCAHTOA using 60 degrees as theta. So when I find the sine of 60 degrees, I'm going to do the opposite over the hypotenuse. When I do the cosine of 60 degrees, we're going to do adjacent. over the hypotenuse. And then for tangent, I'm going to do opposite over adjacent. All right, and then I'll do the reciprocals. All right, so I'll flip that over. I'm gonna have to draw this a little bit smaller. And after you guys do a lot of these, you see the pattern. I think by the time you're done with this, you're gonna know like when it's 2 over the square root of 3 and just automatically go to 2 square root of 3 over 3. All right, and then know that when you have 1 over the square root of 3, just automatically go to the square root of 3 over 3 without having to write it all out. But if you write it out, it's fine. These boxes are kind of small. Okay, we're going to do one more together. We're just going to do the very last one, 330 degrees. So you guys go ahead and turn 330 degrees into radians on your own, please. All right, so the zeros will cancel. 3 goes into 33 and 18, 11 times and 6 times. All right, 330 degrees is in quadrant 4. So I'll draw my right triangle in quadrant 4. Now, all the way around to there is 330 degrees. We want the angle inside, so you may already know what that is, but whenever we're in quadrant 4, we're going to do 360 minus our angle, and that's going to give us 30 degrees inside there. Oh, it's really hard to see, sorry. Okay, so that means opposite of 30 is 1, hypotenuse is 2, opposite of 60 is the square root of 3. All right, in quadrant 4, cosine is positive, so negative sine and negative tangent, and cosecant and cotangent are also negative. All right, and then we're just going to do SOHCAHTOA. So for the sine, we're going to do the opposite over the hypotenuse. Cosine, we're going to do adjacent over the hypotenuse. And then tangent, opposite over adjacent. Now we get 1 over the square root of 3, which reduces to the square root of 3 over 3. Right, reciprocal of negative 1/2 is negative 2. Right, then we're going to flip over the square root of 3 over 2. So that's going to give us 2 over the square root of 3, or 2 square root of 3 over 3. Right, and then when I flip over for the tangent, I just, in my head, go back to what it was before. Before it was
Jaden Brown, please report to Ms. Jernigan's classroom. Jaden Brown.
Originally, it was 1 over the square root of 3. So when I flip that, it's the square root of 3 over 1. Okay. So just one more note about reference angles is, in this case, for these special friendly triangles, your reference angles will be 30 degrees, 45 degrees, or 60 degrees. And when you're finding reference angles, you always use either 180 or 360 degrees. So only use 180 degrees in 360 degrees with your subtraction to find the reference angles. You're not going to ever use 270 or 90. Please don't do it. Just use 180 and 360. Subtract in an order that's going to give you a positive. And so if it's on the 180 side, so quadrant 2 and quadrant 3 are on the 180 degree side, use 180. Quadrant 4 is on the 360 degree side, so you use 360. And then quadrant 1, you don't have a reference angle. You use the angle you're given in quadrant 1. All right, so I hope that makes sense to you. I'm sorry for the interruptions with the intercom, but that's just how it goes sometimes. So your assignment today is to go back and do 90 degrees and 180 degrees. On page 4, and finish both charts on this page.